Hey, we're live. All right. Or so it claims. Then it got rid of my messages. What do you know? What you do is keep it civil. Stream rate error. Bother. Bit rate 23, 26, something or another. All right. See what it says here. I don't know. We'll see how it goes. Looks fairly decent as it is. Lower than the recommended bitrate. All right, well, we're gonna just go with that. Looks good for me. Looks good for you. Looks good from where I'm at anyway. All right, well, welcome back everybody. We are getting back into writing our code and oops. Would be helpful to have the mic nearby, eh? No, I'm most certainly will forget it, I'm sure. But hi, welcome back. Today we're going to get back into doing some more live streaming, in this case with the EUP processor. A lot of the rocketry has been put on hold due to bad weather and being a little sick. So let's see. Where we left off, we had our emulator going. And let's see, it's not showing my mouse cursor. So we had our emulator, which is this big window over here with the red text at the top. And just behind me here, we'll switch over to the smaller window screen. Just, I'm not sure what that noise was. Just behind me is the text editor, gedit, with our colorization file. And if you're interested in how to set up your own colorization file, we did a video on that. Feel free to check it out. I'll hopefully remember to put a link in later. So we have a whole bunch of things going here. Let's see. We got our little good guy, our EUP Invader. Now let's just show you a little bit of our infrastructure. So we're doing our editing in gedit on a Linux machine. And our emulator is also built for Linux and primarily operates on function keys, although escape bails out. And then to get it going again, we generally would compile or assemble our code and then run it, but we can also put it into a nice little shell script. So let's just show you what that looks like right now. We basically just call the assembler on the main assembly file, and it includes all the other necessary files. And then if that succeeds without a problem, then we just immediately call the emulator. And we're trying to set it up to be more or less realistic, so it's fixed at about 20 megahertz. I had a hard time finding the bug. Turns out I was calling clock too often in Linux, and that was actually slowing it down. So we rearranged some things in the emulator, and now we get a maximum of about 30, 34 emulated megahertz. But I'm trying to keep it to 20 just to be a little bit more realistic, kind of like the what you would have dealt with back in the 90s, which is this general infrastructure, what this general infrastructure is based on. Console applications, written in C, using the ANZ character codes for color and position of things. So let's just go ahead and run that again. Start our shell, and there's shell done. Thanks to an earlier misspelling. And then we have a whole set of commands in this shell. We can print an ASCII character set so that we can figure out what special characters we want and what their codes are. And then display things like we can display special characters in hex. So if we do a string of hex values, let's do string 42, 42, and then where'd you go? There it is, 65. 65, 65, and a 21st space. And yes, you eventually start remembering these. Let's see, B 43. And where'd you go? You're around here somewhere. No, you're here somewhere. Where'd you go? Oh, oh. Oh. Didn't look far enough over to the right. 6F. Might as well keep it up consistent at capitals. And 6F. And a final. Where are you? The letter I want. Da, da, da. 6E. And that spells be cool with a double E. Anyway, features like that just help make figuring out what I want to put into the code easier. And then we have a couple of games. We have like a little breakout game. We were going to have a breakout game, but it ended up being more like Snake. And the main one I'm working on is the EUP Invaders, which we start with EI. Boop up, boop. We can move left and right, fire off a dot. If we time our second fire at the right spot, we get an explosion. If we just time it, there we go, there we go. And so you can see we've got some basic infrastructure going in the game. Now we just need to tie it to functions. So for example, we've got our shields, and when you hit the shields, they're going to degrade in several steps, and then they're going to go away. And we don't have a convenient way of reading back from the screen what's currently on the screen. So instead we have this whole block of text. This block of text. I need something, why, let's see. Screen capture, show cursor, it doesn't show cursor. All right. How do I go about showing a cursor here? Well, we'll fix that next time. But anyway, the shields, the blue guys down at the bottom, you see when they first start up, we'll quit and come back. They come through several different shades, and these are the shades here. They are DB for the solid shade, B2, B1, and B0. So the goal is I fired a dot, I hit one of the spots, and then instead of being a DB, it gets replaced with a B2, hit it again, becomes a B1, hit it again, it becomes a B0, and then after that, it gets replaced with a space. So what we need to figure out is where is my dot in its travels and whether it is likely to run into a shield. So we know that the shield is going to be between this row and this row, which if we look back at our drawing the shields, draw the shields, check for the boom. Let's go look for draw shields. Shield block row is 16. Draw the shield block on 16, so we load into B. Load B from an immediate an EEPROM value. The shield block row, and shield block row is a constant that's defined as 16. So that loads 16 into B. Then we load 1, which is the LAO, into the A register. Everything in ASCII is 1 based. Ugh. Everything else in C is 0 based, but anyway, that's how it goes. So, and then we call the function set the cursor position based off of what we placed in A and B. Then we load the location for our shield block, and our shield block is defined in our assets, EI shield block. It's defined as a variable in ROM with space for 255 bytes. And there's the degrade process that we're looking at. Again, it doesn't show the cursor at all, does it? Anyway, there's our series of degraded blocks. And let's see, where did it appear? Here's the shield block defined in ROM. And all right, okay. Let's see, what else do we got here? So, how would we find that we've hit this block here, the one that's right above our good guy right now? We would have to know what row it is. So we are going to have a function to detect whether we hit the shield block. Hit a shield. So we need a shield hit function. Draw the shield block, draw the bullet, draw the good guys, move left and right. Here's our go boom, generic go boom function. And it does the same kind of thing. We load the bullet row and column, and then we call explode, and we draw that explode. Let's see, so what we need to do, so we draw the explode, that's the explode animation, and then we blank that area out. And we increment to the stack 2 and return. So let's go boom. So we want to do essentially go boom, but we want to detect that we've touched that. And to do that, we will need to know what character, well, again, let's see. So this is actually go boom. Where is go boom called from? There we go. We call check for no boom. Check for no boom is this. The bullet row is loaded into B, and then we're checking if it is loading DNR with 3 and 6. And in range B. So the function in range B Oh, come on. In range B, set in the util functions. Yeah. Check if the input is greater than the D register, and then check if it is essentially less than the R register. So then we get a to either be 0 or 1 to return. It's probably going to be not 1, but something other than 0. So in range B. So this is the check for no boom, and it's stated that way because it comes back backwards. So let's do a check for row boom, or shield boom, let's call it. Copy that function. Check for shield boom. And let's see, so we got our bullet row, load that in. Then our range, let's see, instead of being between 3 and 6, and mind you, this one here is considered 1. So where did we put the thing to begin with? Check for shield boom. Check if the last bullet might have hit a shield. And does the row and column. We really just need to do the rows, and then we're going to check the RAM for that character. So we're probably going to have to start single step in here soon. But let's first see where we place the row, or where we place the shield row. And that is going to be in, see if I can find that here. Here's main loop. Shield block row is 16. That's a variable, so let's go ahead and, I believe that's the top row, and they're made of 3. So let's go ahead and copy that. Go back to where we were checking for a shield boom. Instead of loading 3, we will load the shield block row. And how best to do this? Let's see. Let's go back up here. Let's just make the constant so that we're not wasting time doing addition. Shield block row base. That's 19. So that would be between 16 and 19. That should be the 3 rows. And although that seems off, and the reason it seems off is I thought 16, 17, 18. I thought that our good guy row was 18. If you have to be civil, you're not going to stay around. Alrighty then. I could have sworn our good guy row was 18, so let's find that. Oh, good guy row is 19. So 16, 17, and 18. Ah, yeah. 16, 17, and 18. Shield block row. So it's 16, 17, and 18, not 19. There we go. Shield block row base. Wish this thing would just scroll back to where I was last, but anyway. There's our go boom. Check for no boom, check for shield boom. Boom block row. Shield block row base. Oops. All right, so we load into D, and immediate constant that, and R that. Then we're going to check if the bullet row, which was, so what this did was it loaded the address of bullet row, a variable. And then it said load the contents of that address, dereference that address into the B register from memory. And if you have any question about all of these instructions, we have a nice, well-documented user's guide, including all of the instructions in the instruction set, the logic behind the essentially lookup table-based sequencing of the processor, and its basic layout. So all of that's up on the GitHub if you want to play along. We will be updating the emulator improvements here shortly, once I get finished fighting with GitHub on both Linux and Windows. So anyway, we come in here, we load our bullet's current row into B, we load D and R rather, are loaded with the top and bottom row. Then we call if it is in the row range. So the return from this, I guess I could just add some comments, eh? Who wants to see comments? Hey, Mr. L, how's it going? Would you like to see me comment as I go? Just, you know, So what I'd rather do for comments is we're going to sort of put in the quote C reference of it, if you will. So these two lines here, essentially do dereference bullet row, which is of type byte, and place it into the B register. So B equals dereference a bullet row, right? And then these lines, LDE and LRE, are D equals a constant, which is the shield row constant. And same kind of thing here. The R register is equal to the constant shield block row base. Then we call this function here, which, although I'm not saying A equals, in assembly a lot of parameter passing is done directly in the registers. So this is essentially A equals the result of in range B, so like that. Now, in the processor, loading a value into the B register will automatically reset the processor flags, the primary one of which is the not zero flag. So this is B equals A, sets flags. Make sure I'm not typing into my own face here on the screen. Now, check for shield boom. Let's change the constants while we're at it. These are go-to labels, essentially. So that's going to set our flags. Then we are going to jump if the value in B is not a zero value down to this next section, which is going to check for whether it's in one of the columns, right? Well, our shields could be anywhere across the entire bottom. So really I'm going to change that to checking whether or not the column position in our data for that row is a character other than a space. It's rather complicated to say, but so CF SB, this is my way of saying that we're now going to jump, because jump long, 16-bit jump. If the value is not zero, to this label, which is check for shield boom CFSB dot, it's not next. From the row section down here, these can all be obviously anything you want them to be. They're just jump labels, so defined with the D instruction, which you can also find in the documentation of all of the assembly and commands syntax that we have for it. So, all right. We found that it was within the range, because if it is the return of in range B sets A to 1 or 0, we set the B to A, then we can check the flag, the non-zero flag. That if it is non-zero, it means it succeeded and it is within the range. If this jump had failed, we would load 0 or load 1 into the A register. That's why it says it previously was not boom. So this function, check for, let's just go ahead and put the comment, shall we? Returns A equal 1 if not hit. Not a hit. So I wonder if I might want to do the whole replacement here at this level. So there's our return statement. So that's our return early. Let's go ahead and put our comments in here. If B is not 0, go to CFSB dot in row. And then of course our condition otherwise is A equals 1, the constant, and return. So obviously when I normally write this without talking about it on stream, I don't add in all the comments, but this is here so folks get the idea. So here we previously checked whether the bullet column, which we dereference here, So this is B equals the dereference of bullet column. I don't know why I'm adding semicolons. Too much C in me. So here we would normally check if it was within these two positions range, but we're not going to do that this time. Instead, what we need to do, and this is where it's going to get a little bit more complicated, is we have to figure out from the row and the column that we're on. And actually, I think I need to know the row first. Yeah. Because what I'm going to want to do, sort of do these in backwards order, if you will. But we want to do this again. We have determined that the bullet row is within this small range of where the shields are. So now we want to take the bullet row and put that into B. Then we want to load the pointer to this string of data, which is the shields. And the string of data that is the shields is our EI shield block in DRAM. This is copied from ROM into RAM early on. And so capital V is create a variable in RAM named this. The little lowercase a sets the size of it. So these two lines combined are the equivalent in C of CHR. Everything's char pretty much. Shield block D 2 to 255. That would be the C equivalent of that. So we got our shield block D. Go ahead and save our resource here. And we are going to load that into the DR register. So this is just the DR register, which is a 2-byte register. You can see it up here changing rapidly. Really wish I could add a pointer. I have to figure out the pointer. Let's see, what can I do for a pointer? Oh, I know. Let's go ahead and add a color source. Call it highlight. Oof. Well, that was way bigger than it needs to be. Let's call it 20 by 20. And let's give it a more useful color, like a yellow. It's maybe only half transparent. All right. Now let's see, we should be able to drag this guy around screen. So here is our DR register. Go take a look at how that looks. Yeah, there we go. It gives us something to drag around the screen anyway. Got my logo on my face. I didn't realize that. Oh well, whatever. Getting a bunch of warnings about the stream bit rate. Well, fix that later. Seems to be okay. If I'm looking pixelated or something, let me know. So there's our little yellow dot that I can drag around now. just park that there for now. All right, so back to our text. Our DR register is now going to be equal to the value of this. So everything in here is pretty much a pointer. And then I dereference the pointer by using this combination of loading it into the DR register and then dereferencing the DR register using the DR register contents to look at a memory location and then load it into B. So LBM is use what the current location in the DR register to read a byte from memory. And in the case of M, it's from RAM versus I forget the other one anyway, but again, that's what references are for. So LBF or LAF, LBF are all load from the ROM. So M is memory, E is immediate, M is memory, E is immediate from ROM, meaning the next byte, and F is from ROM based off of the DR register. So here's our bullet row. Got that. Got our location to our shield block. Now we need to do a little bit of math. And unfortunately, we do not have a multiply operation in our ALU. So we're going to have to add several times instead of the math. Nothing like creating a more complicated puzzle for yourself. So our bullet row, we have to subtract our 16 from our bullet row to give us the row offset. So it's either 0 for the top, 1 for this middle row. Grab my thing here. It's either 0 for the top row, 1 for the middle row, or 2 for the bottom row. And so we're going to do it 0 once or twice, right? The best way to do that, probably not the best way, but a way to do that. So let's do the subtraction first before we load that up. So right here we've got our B equals that. Now we want to subtract the top row. So we're going to load into A, the top row. A equals the top row. Then we want to subtract the bullet row from the top row. So we want to subtract A from B. So that's a minus. A from B. Is that minus A from B? No, that's minus. This is the equivalent of A minus equal B. And is that what we want to do? Yes, that is what we want to do. So A has now will either be 0, 1, or 2. And in this case, because we're firing right underneath the guy, we're going to be probably a 2, right? So do the subtraction. This is most likely going to be 2. And the width. Let's go ahead and take a look at our asset again here. So it looks like it's 80 columns, yeah. So you'll see a lot of people have done this kind of thing in the past. It's essentially a character ruler. So our entire shield block row is 80 characters, even though most of them are spaces. But that's done for convenience for the math. So now it's 2 times 80, which would be 160. And that'll get us to the memory location that is the start of this row. And then we can add the column offset. And that way we know what character we're dealing with. Sounds easy, right? All right. But we don't have a way to multiply. So, we can do it in a loop, because multiply is just addition in a loop. Right? Now, are we gonna go out of range? Remember, our numbers only go from 0 to 255. So 80, 160. Ooh. We might have made ourselves a conundrum. Hermditor. See, that's 80. What the heck's 80 times 3? 240. Okay. We're good. Also, because the column is not going to be all the way over here or all the way over here, because our little guy, even when he goes all the way over to this end, he's maxed out. So he actually only goes from column 2 to column 79, I guess. But since we've got that, so our shields never move. We could ease our mathematics probably by getting rid of these blank spaces here. Just give us a little more space in the math. And I guess I should make a constant for the width of this. Shield block length is 80. So since we don't have addition, but we can do multiplication in stages, or we can do multiplication by adding in stages, and we have essentially the equivalent to a for loop or a while loop. I think I'd rather switch this up. Let's put the bullet row into A. Subtract it from from B, so that B holds our result. There we go. So load the bullet row into A, load the starting row into B, subtract the bullet row from the starting row, Am I going to do that upside down? You know, this is the time where we should probably just go ahead and start testing our math. Let's test our math, and we can do that by just halting this here. Put a temporary breakpoint, if you will. Save that. Now the rest of this is pretty bad logic, but we don't really need to worry about it yet because we can run over and over again. So same place that we call check for boom, or check for no boom. Here we call check for no boom. Yep. And for now, let's do a call check for whether we hit the shield boom, right? And really, we just have this in here, like I said, as a temporary code. So all right, that's good. Let's start single stepping instead of speculating, shall we? I'm surprised I've gone this far already. All right. We've got all of our code ready to go. Yes, 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 it looks good. Quit out. Do our rebuild and rerun. Oh, we've got a problem. Let's see. Code line 278. Oh. Gee. Really? 278. 278. Haha. Redefinition of symbol. That's what we get for block and copy. We'll make it that symbol. We'll make it that symbol as well. Notice that if we had actually run through this code, meaning we didn't include this halt right here, we were going to run back into the other functions midpoint. There's no concept of local versus global symbols in assembly. Maybe there is an actual assembly, but not in my assembly. So we could have easily jumped from this out to the middle of that other function, which is where you get all the caveats about not using goto, because you end up with spaghetti, if not spaghetti logic, spaghetti execution. So we got all that to save, and make sure we save our files before we try rebuilding. Oh, good, it worked. Then want this to be an immediate boom. So if we fire our bullet, that's not good. Mr. Bullet, you were supposed to go through that check function. Check for shield boom. So what is this? There's the fire button has been pressed. Our shot has been fired. We load that into DR, then we call the increment the shot counter function, and then we should have hit this. So let's see, why aren't we hitting this? Let's create another halt there. There we go. Now we hit halt. All right. Then We hit halt. So now we check for shield boom. Yep, we jumped into the function. Every time I do a halt, it's actually on the next instruction that's about to be executed. So we're going to load the register or load the location for bullet row into DR. Oops. So there's DR, right? We loaded that location. And the next step, you can actually see the disassembly here as well. This is our location in RAM. So this top row is the location in ROM, and the second one is the location in RAM that we're most currently looking near. So the DR 0E3D, there's 0E3D in RAM, and 0E3D, which is 0 for some reason. Oh, well. Why is it 0? Because it hasn't fired yet. So we've loaded that into B, and we loaded, you'll note that the variables change color when we update. So B is 0, which is as if the bullet has not yet been fired. All right. Well, so it has not been fired, so it shouldn't be in the range, right? So let's say we load D, the field base, 16, 18, and of course I wrote them in hex instead of decimal, which I guess they're all in hex instead of decimal, aren't they? All right, so now we're going to call if it's in range B. So we jump into the end range function. We load into A the contents of D, which is 16. And while I'm talking here, you be looking up at these registers over here for what's happening. Now we're going to subtract A equals A minus B. B was 0, so that didn't make a change, right? And then we're going to jump if the borrow flag is set, which it is not. Then we are going to jump if it is something other than 0, which it should be down here. It's not in the range, so we set A to 0 and we return. Now we're going to load B into A, which of course is 0. Lots of zeros going on here. And then if it is something other than 0, we're going to make this jump. We do not make that jump. We make A equal 1, which it is, and we return. All right, now let's, interesting. I thought this was in the main loop. Fired, check for the boom. Let's see where else we check for the boom. That's the function declaration. No, that's the only place we check for the boom. And this is definitely the right when it's fired. Oh, that's right. Previously, I was only checking when you fired the button, fired the pellet, whether the previous pellet was in the range. It's going to be kind of annoying to try and do when we're this close. And actually needs to be done elsewhere anyway. And we're going to take that out. We play the bullet sound. This is the bottom of our do loop. So I guess we should check the bottom of our do loop. Because we didn't fire. Check for no boom. We didn't boom. Otherwise we go boom. Whereas and increment our time on target. Boom. All right. So we're not firing, but every time we're not firing, every time we go through this loop, we need to check if our bullet has collided. Previously, I was only checking it every time you hit the button. And that made for an interesting little game, but not what we're looking for now. So this is going to happen every single time we go to move. It's going to be a bit of a headache, but not unmanageable. All right. Quit. Rebuild. What'd you do? Unknown command 412. Our assembler is very column sensitive. I'm not parsing based off of spaces. I'm expecting if there's a character in this third column, it should be an instruction. Hey, Last Raise, how's it going? So our assembler is pretty harsh and exacting in its formatting, format expectations. So now every loop through the game, we're going to halt and check for the call to boom. Kind of makes me want to put in temporary breakpoints or something to that effect. All right. Yeah, looks like it's, no, that's, so we're only going to hit this if we hit a key. Yeah, bonus. We hit it only if we hit a fire. But that's not really what we want either, right? We want it to be every time. But anyway, so hit fire. Let's go into it. Single step. We go in, we load the bullet row into B. Bullet row B is 19. And that should be not in range. Now hate when keys are not where I expect them to be. All right. Call check in range. It is not in range. Set the flags based off of the return value. It is not in that range, therefore it is not a boom, and then we come back up. Now, do we hit this again in the next? No, we don't. All right, so that's not a good place for this either. I thought, let's see. Yeah, main loop. Copy constant, where we set up the shield. And, oh, there we go. Draw the good guy, draw the bullet, draw the shield block. This check port for key is what I was not doing earlier. So here we go. We draw the bullet, and then we are going to do it and check it before. Let's check it before we draw the bullet. This definitely should cycle around every freaking call or every freaking loop. Escape, rebuild, start the game, and sure enough. So we have to if I hit A while it's paused, we should see it show up in port 2, port 1 rather. So these ports, port 0 is the output port, port 1 is the input port, port 2 is the special function port that includes making noises. So since we're here, if I hit the A button, there we go. Port 0 gets the A. It's a lowercase a, by the way. And then now, if I actually use the function key to single step and check for boom, we're not going to be a boom. Let's move. So now our character moved. That's bonus. We need to do that a couple more times. Let's do A and F5, 5, A and F5, F5, A and F5, and there we are. Now we're where we want to be. Except we haven't pressed the fire button. So let it run one more time. Now we hit W. Note our port value is changed to 77. Now we're about to fire. There should be no shield boom because we haven't actually fired yet. So let's go ahead and run. There was the beep of the bullet being fired. Now we're going to check if we hit the shield by single stepping. So load the bullet row into B. There we go. Bullet row B is 19. So we load. Really got to keep my keyboard here. We load the top of the range of 16 into the D register, the bottom of the range of 18 into the R register. Then we're going to check if it is in range. And I believe it should come back with value is not in range. because it's a less than, well, it's between 16 and 18, and it's currently 19, right? There we go. So our bullet is currently located in 19, and we're checking a range between 16 and 18. So that would be not in the row. Correct? Yes, correct. So we return, sets the flags. We're not in the row. Let's go ahead and return. Run one more time through the loop. Go back into chicken. Now we load the bullet row, and the bullet is at row 18. Right? Yay, bullet at row 18. Bullets at row 18. Load 16 as the top and 18 as the bottom into DNR. Call in range B. Do the subtraction. If there's a borrow. So looks like we're in range. Let me delete that. There we go. All right. Get back here. So we are doing the secondary check to see if we're within the range. Do the subtraction. Value is in the range, so we set A to 1 and we return. And we load B with the contents of A. That sets our flag. So if we are not 0, yeah, all right. We got our basic logic going now. So all of that was to check whether or not we were in the range of these three, rows, and to find out that we were at the base of row. So now what we need to do is what we said before, which is, well, let's see, our bullet row. We're going to load our bullet row here. Well, load the address, dereference the address. So now our bullet row is in A. Just remember when I start mentioning A, B, C, and D, I'm talking about A, B, T, D, and R are two separate bytes, but they are a 16-bit pointer. There's your stack pointer, your instruction pointer, your instruction register, and the port values, each of the 4 8-bit ports. So when I talk about the registers, these are the registers. When I talk about RAM locations, you can see the references to RAM locations down here. So every time we set the DR register, we then show what that row of RAM looks like. And every time we set the stack pointer, is it stack pointer? No, the instruction pointer right now. So the instruction pointer was showing you this first line here is the next instruction. So we actually see our next instruction is LBE. Down in the source code, it's LBE. So everything's nice and synchronized. Realize what it takes to write your own debugger. It's kind of complex. So now we're going to load the shield block row, which is the top row, into LBE, or into B, using LBE, right? So our bullet's on 18 in A, our top row is 16 in B. We want B equals B minus A, which is that instruction, minus M for minus. And that gives us FE, which means we got it backwards because we can't go negative, and that's obviously a negative number. So really what we wanted was subtract B from A, right? A minus equal B. All right. Well, that was a lot of work to get right back here. And I just realized we're going to be there just starting in the center anyway, so we don't have to move our ship first before we fire, and that'll save a few cycles. There we go. No point in checking for a shield boom because we hadn't fired yet. So let's go ahead and hit W to fire. Note we'll change P0 has changed. Every value that changes turns magenta. Every value that's the same as before is white, I guess, or grayish. It's actually a shade of gray, but anyway. So single step on just also, so you know what function keys I'm hitting here. F1 gives us help, F4 resets, F5 to run, F7 is return, but it really is run until you hit a return, the RTL instruction, which may not be the function you're at, it may be one that you're under. So it's not always as useful. F8 just halts at random. F9 is a tick count, so it runs through each of the steps in the microcode as described here in the sequencer and sequence map and control registers. If we're debugging microcode, we would do a lot more F9s, but F11 is a step, and that's because it used to be F10, but Linux likes to do special stuff with F10, so it's F11 now. So that's the quick little help reference. So we're halted. F11, we get into the bullet row, or the check for shield boom, right? So let's load our bullet row into B. It's currently 0. That's boring. Run. There's the beep of the bullet being fired. Let's step into there. Now we're in our bullet row again, loaded into B. It's row 19. Do our comparison. Can't hit F11 too fast. Otherwise, the wrong window gets the character. All right. And it's 19, so we're still not in it, right? There we go. Now let's load the bullet row into B. It's 18. Now we're going to be in the right section. And that's where I realize I should have put a halt after this. Wonder if I can, this level of debugging, I really want to be able to set a breakpoint. No breakpoints for you. You have to install halt instructions. My kingdom for a breakpoint. So, anyway, we'll just step through it. So it's going to call in range B. Now here's where F7 is supposed to run until we return. That worked well enough. Load that B. There we go. And we can do that. So bullet row. Load that into A. It's 18. Our shield block row into B. Right? Now we're going to subtract them. And we get 2. Yay! We finally get the number of rows from the top of the shields to where our bullet is. So, now we want to find out whether this space, the space right where our bullet is, we need to find out if that is got a character, the value, if that is a space character or a shield character, right? Yay, what fun. Everybody with me along so far? I mean, it's only been an hour and 16. Or it's rarely quick writing in assembly. All right, so let's see. All right, so we got the math worked out, right? So now that we've got our math correct, this is where we want to add this 2. What we want to do is take 2 times the length of the shield block see, can I undo that? Yay, okay, I can just undo it. We want to take that 2 that we've calculated that's currently in the A register, multiply it times the width of a row, which is 80, right? But since we can't multiply, we have to add. And we know that that value is currently, we know it's 2. So if it is, did I have a multiply? I thought I had a multiply function. It'd be a smart thing to write, right? Multiply function. Util functions. Int range. Xclass. Get line. Could have sworn I did a multiply function. Yeah, somewhere in here is a mul BA. It might be in our math functions. Game libs, program libs, standard libs. Yeah, math. There's our math library. Integer divide. There we go. Multiply B times A. So we already got that worked out as a function. That's good. That'll make things a little easier. So multiply B times A. So all we really have to do is load. We already have our 2 in the B, in the A function, right? Now we need to multiply or add, load into B from RAM, the width, right? There we go, our length. So that is going to go and be B equals that constant. Now we're going to call multiply BA. And if I remember right, yeah, it doesn't multiply by multiple addition B times A with the result being in the DR register, which allows for it to be the result to be greater than 255. But since we're then going to do an offset and we have to add that, I don't think I have 2 16-bit multiplies. Yeah. We have So divide 8, divide B and A, which is actually more of a modulus function. All right, well, there we go. We'll multiply BA. DR is going to be the result. And for convenience, DR should be less than 255. So that's mol BA. And then after we've multiplied that, we have DR is the result, R being the actual value we're interested in. So we're going to load into B the R value in case it's 0. In this case, at this stage, we know it's going to be not 0. So B equals R. We should test, now that we've done that, now we should test. Let's just put a note in here. Do test for not 0. But for now, we're just going to, because we know it's going to be we know it's going to be something other than 0, right? And now that we have that into B, now we load. All right, now we have that into B. Now what we need is the column, right? The shield column. So to get the shield column, we're going to load into the register our shield block column so that we can load into A from memory the current column. Then we're going to load the block pointer, right? And then we're going to add, which is epsilon or E in our instruction set, because everything's a 3-letter instruction, TLA instruction set. So we're going to add with the destination being the DR register, whatever is in A. So, looks super complicated, I know, but this is the order we have to do because we have very few registers to work with. So, these two commands mean A equals the dereference of the block column. This is dr plus equals A. This is dr equals A times B. All right. Now B equals R. These two lines. Let's just put a comment there so that we know that it's the line, that we've compensated for the line. All right. Shield block column A equals the shield block column. The shield block column. We don't want the shield block column. We want the bullet column. There we go. So if we have done this right, we have right. We want to do EDB first. We're going to add dr plus equals b for the row, dr then plus equal a for the column of the bullet. And at that point, we should be pointing to the location in memory that is right where the bullet is within the block of shields. Simply, boy, you want to create yourself your own freaking puzzle, huh? All right. Yeah. So don't need all of this can go away. All right. Now our DR should be pointing to a location in RAM that is our point right above the bullet. In this case, it should be a space character. So managed to check all of this logic is correct. So let's put a halt here. And then I think we can get rid of our halt just above check for shield boom. So depending on the return of check from shield boom, we'll either draw the bullet or it will have hit something and it won't be drawn. Yes? Yes. And then also we will dispose of the bullet. And I believe I dispose of the bullet by setting, I forget. I'll have to check that, but one thing at a time. There we go. Check for shield boom. Ready to rock and roll. Let's try out some code again, huh? Amazing when it assembles without error in your first try. So, fire. All right, we know it's not going to be here. Oh, actually it is here. What do you know? Because the bullet row, right, okay, bonus. So we didn't see it, but we should be about to hit this one space right here. So now let's see if we manage to do all our math correctly. So load our bullet row is 18. Right, that's good. Load our shield block row. Is 16. Subtract them, we get 2. Then we're going to load the shield block length into B. That's 80. Good. Now we're going to call multiply of those. And we tested that, or we trust that that's been tested enough already, so we jump out. And our DR says it is out of range. That doesn't seem right. Oh, because it's not 80. It's not 80 because it's not in hex. It's 80 in decimal, which is what in hex? Come on, chat, help me out here. Let me do my conversions. 80 decimal is what hex? Anybody got it? Anybody still there? Hello? Bueller. Bueller with the calculator. I suppose I should find a way to make my constants not in hexadecimal, eh? Yeah, should probably do that. All right. 80 hex. You know, one way that we can find out, we can quit the program. What's going on here? Why does it seem locked up? What's going on? Something's weird. What's gone sideways now? Huh. We seem to have stopped responding. Oh, that's why. I hit F10. Is that why? No. Emulator has locked up. Well, that's problematic. Not too problematic though, because we just spawn a new column, hit that, close that terminal. And we can build and run. There we go. I suppose I should put a little feature in here that would convert for me. But otherwise, I guess I'll use the calculator, because I don't have too much hex conversions memorized. Programming. So 80 in decimal is 50 in hex, or 50 to be more correct. All right. So this should be 50, since all of our numbers are hexadecimal based. All right. So run the game, hit fire. Load the bullet row into A, 18, the top shield row into B, 16. do the subtraction. It's 2. Load block length. What? Yes. Shield block length. What? Shield block length. Oh. Didn't rebuild. Fire. Now we should be doing it right. Get our 2. Shield block length is 50 in B. Thank you very much. Do our multiply. We get A0 is our offset in the R register. That looks good. B equals R. Now we load our bullet column. And we put that into A, which is 28. Then we are going to load our shield block all together. And as you can see, we loaded our shield block location. The very first location is 0. So what you're seeing is space, 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 solid block, solid block, solid block. Right? So that's the equivalent of these space, 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 and then these 3 solid blocks. All right. Now we're going to add B to that to get to the appropriate row. The start of the appropriate row. I think. I'm off by a little. See? That A there. It shouldn't be 20, 20, 20. And then A should be this location. So I'm off by 1. Well, off by 2 actually. And that is because at the end of these rows, my carriage return character. So it is not 50 in the width. It is 51 in the width. Nothing like an off by 1 error to make you know you're having fun, eh? All right. And fire. All right. Bullet rows 18. Top of the shield is 16. The difference is 2. Length is 51. Multiply that. We get, oh, we haven't finished multiplying. Finish multiplying that. We get A2 is our offset. Store A2 into B. Load the bullet column into A. Load the starting of the shield block into DR. Add the B offset to it. That looks right, because there's our carriage return, and then space, 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 space. 1 block and then another space. And that's the equivalent of this down here with space, 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 space. 1 block and then more spaces. But now we need to add the we're about to add the 28 to it, and sure enough, it's a space. Now that we've done all that, we can check if the position is a space, and it is, so now let's see, now we're going to load this in. We need to, so our DR register now points to the location of our bullet, and our bullet is on a space character. So now we need to load that space character into someplace. That's never going to be 0 because we're looking at characters on screen. Or is it? It shouldn't be 0. But anyway, let's load that into B now. LBM. B equals the dereference of DR, which is our bullet location, right? And we need to check if that's a space. If it's a space, we just return. So to compare it to a space, we need to load space, right? So load a constant of 20, the space character, which I may or may not have a constant for. Now, what you do to find out whether the two things are equal is you subtract one from the other. So we are going to minus, and we want to keep the B because we bothered to went through all that stuff to get the character. So we're going to minus into A, B. So that means, oops. So this is A equals 20, which is space character. Then A equals A minus B. So if they're the same thing, we end up with 0. If they are different, we will either be something other than 0, right? We'll just be something other than 0. So if we're something other than 0, we're going to continue our processing. So we're going to jump along, if not 0, to CFSB dot, let's just call it not space character. So that's jump to not a space, and then we're going to do something with that. It's actually, I guess that means if it's not a space, it means we hit something, right? We hit something other than a space. So our bullet contact a square that's something other than a space. So doesn't mean we go boom just yet. But then if that fails, then we return and we've done nothing. And we should render our bullet. So let's define that symbol. So we don't get an undefined symbol error during assembly. And right now we don't do anything else, right? We're going to do more complicated stuff. Change the not space. So we have to do this whole thing where we exchange one character for another depending on what character it is. And that'll be a whole nother function. But for now, Let's see, so this means that A, or rather B, is not equal space. Because if it was, the subtraction would have ended with a 0, because the two things were equal. And so we return. And just to make sure we don't go out in the weeds, we'll put a halt there for our continued debugging fun. Yes, let's run through this one more time. And fire. Road. Our bullet row is loaded into A, that's 18. Our shield block starts at 16, and the B, we subtract them, we get 2. We get our shield block length, which is 51. Multiply B times A, we get an offset. Oh, we're still in. Step out of that. So we get an offset of A2. We move A2 into the B register. From the R register, we then load the bullet column into the A register. We then load the start of the block of memory with our shields in it. To DR, we add the row offset. We add the column offset. Now we load the character that's at DR into B, which is a space. We load a... What? Oh. I'm going to have to figure out how to make this more consistent. That needs to be a hex value. So since we got this far down, let's move this halt statement from here down to here. Oops. All right, so I forgot that when I do constants, it seems super inconsistent, doesn't it? So here, if I define a constant, it's defined as a hex value. And then here, if I define a constant as a hex value, I have to do the prefix. You know, whatever keeps you sharp, right? Anyway, we moved our breakpoint down so we don't have to go through quite all those same steps. Save our code, escape, rebuild, reload, rerun, fire. There we go. Now we're about to, we load into B, the 20. Now we're going to load into A, 20. Yes, that worked. Now we subtract the 2, and A is 0. And you'll note the flag is the 0 flag. Let's see. So flags are up here. The borrow, the carry, the oh, now I forgot what that was. I'd have to look that up again. Anyway, the last one is Z. That's the 0 flag. Or I should say the not 0 flag. So we're going to jump, if not 0, to the space, which shouldn't happen. And right, and we return. And then we're going to draw our bullet. There we go. There's our bullet. Flew right through it. Because we're stopping for each row. Are we stopping for each row? Let's try that again. Now we should fire a bullet and we should hit that square, right? Fire a bullet. We've loaded still look like we've got a one-off error. You know why we got a one-off error? Because this column over here, this is not 0 based. This is 1 based. So I have to subtract 1 from the current column for our math to work properly. So up in here, where we did the multiply, right? Here's where we added 1 for the column. But in order for that to be correct, we have to subtract 1. So let's decrement A. Actually, DED, decrement the pointer. Right? So DR minus minus, because our columns start at 1. All right. Because we should be looking at that DB character right there, not a 20, not another space. And you're beginning to see why C is 0 based. Super based. You're not based if you're not based on 0. This makes the math easier. All right. One more time. Going through here again. Quit. Rebuild, restart. Let's see. We can move without firing. Now let's fire. Boop. Let's scroll this down a bit. All right. So we're about to load into B the current bullet location, which is looking like it is correct now. Right? Yep, it's the DB character. Now we have our block in the B register. We're going to load 20 into the A register. Then we're going to subtract the 2, right? And since our borrow carry, our borrow flag is set, let me double check. I forget what those flags are. Flaggity flags. Come here, flags. Carry, not 0, borrow. Carry, not 0, and borrow. Oh, that's right. So the B is ALU busy. Carry, no, borrow, carry. Seems off. Anyway, we'll work that out. But in any case, let's see if this jump works. The jump worked. So in any case, it's something other than it's not 0. Something other than 0. Which is the N flag. Yeah, N is not 0. Yeah, one of those is the ALU busy flag. And there's the borrow. I should really have renamed them better. Alright, so it's not a space character. So now we're supposed to do something with it, right? There's a couple of things that we need to do. But for now, let's just turn it into a space character. And make it to where the bullet hits it once, it goes away. So to turn it into a space character, we are still loaded with our DR register, that space location, right? So change the not space character into a space character, and we have to kill the, we can make them degrade later. Right now, let's just make them each go away every time a bullet hits it, right? So let's change that not space character to a space. Our DR currently has that location. So let's load into A0x20. So let's load a space. Load space into A. Then we are going to store, load and store. Yeah, load and store. Not load and store. What was it? Come back here, instruction set. It is store, store indirect from A. Store indirectly using the DR pointer from whatever's in the A register. The general pattern is the first letter is a command, second letter is a destination, and the third letter is a source. And by keeping it to 3 letters, it's nice and convenient and everything fits on screen, but sometimes it sounds a little cryptic. So what this is effectively doing is dereferences the DR register equals A. Is setting it as a space. And I guess I should put the alt above that just to, well, we've got this alt here. So that sets the space. Now, the other thing we need to do is to end the flight of the bullet, because the bullet has collided, right? So to end the flight of the bullet, we used to do this. It was for no boom. So check for no boom. It would call go boom. Go find go boom. Here we go. We would so here again, these two rows amount to A equals dereference bullet row. Here is push A onto the stack for later use. And I don't know that I'll need to do that there, because here we were drawing the bullet. Yeah, this isn't ending the flight of the bullet either. Anyway, B equals dereference bullet column. Oh no, I should say A equals the dereference of the bullet column. And then A minus minus. And right, this is because we were trying to find the location of the where to draw the box. So we wanted it to be on the row, but we want the column one over so that we can draw the box. So anyway, push A again, which effectively stores bullet column -1 on the stack. But notice it doesn't, well, I can notice that it doesn't do anything to the result of the bullet. And I think it's because that wasn't done in the no boom. It was done the second time the bullet was fired. And that's because all I was doing was the second time a bullet was fired, I was changing the bullet column again. Right now they just fly until they hit the top. So what I need to do is make it to where we did not fire. Do that, I can set the bullet column or the bullet row to 1. And I believe the logic is to stop having it fly if its row reaches here. So that should stop the bullet from flying simply by setting its row to 1, if I remember correctly. Yeah, Well, we can find out by checking draw bullet. Bullet row. So if it's not 0, we want to not 0. Set the cursor position and such. Erase the old bullet. Right. I believe if we set the bullet row to 0, because this logic is B equals dereference bullet row, jump if not 0, down here, and then otherwise we're going to jump along to the return location, right? So if B go to not Z. Otherwise we fall through the here, that goes to return, there's our return, then we no longer draw the bullet. So by setting the bullet row to 0, we can stop it flying. All right, good enough. So now we've figured out how to stop our bullet flying. We've changed the color and we've stopped the bullet from flying. Let's see. Check for shield boot. All right. Change the space to 20. Then we load the bullet row location. Load yeah, we already stored it off, so we can load A with 0. And we can store indirect A. And this is set bullet row equal to 0. And I do that anytime it's anything other than that, and we still have 0 into A, and let's see, do we even reference this? Doesn't look like, so we don't need that symbol anymore. Current A is already 0, so we can return. And then the only other thing is, let's leave a note for later. Play hit sound. All right. If I have done everything correctly in the last 2 hours, we should start deleting. Our bullet should be running into shields and deleting them. Jazzy. Everything's good to go. Let's get rid of our alt point. Yeah, flies nice. Whoop. Whoop. Hey. Yay, we did it. We now managed to delete our shields as we run into them. Now it's just a matter of deleting them in a series of steps instead of all at once. But it doesn't even look like I got a chance to draw the poor thing. I don't even see it. Yeah, don't even really get a chance to see it drawn. Maybe we should draw, well, because if I draw it, draw it before the check. Yeah, let's do that. Let's draw it before the check. Draw bullet. Good guy, draw the bullet. Here. Check for shield boom. Let's check for shield boom after we draw the bullet, so we get a chance to see it flying before we actually determine. Let's see. It might leave bullets behind because we didn't we replaced the space in memory, but we didn't replace the character that's on the screen. Although we're going to draw the shield block anyway, so that should clean it up. All right. Everything's saved. Fire. Still don't really see it. Everything's drawing too fast. Should we draw the shield block first? Should the bullet be the last thing we even draw? I guess the bullet should be the last thing we draw, and then we would check for the shield boom, and that way everything gets this delay in it for a sec, you know. Let's do that, because I was wondering about that, because I had seen that before where it just didn't seem to show the bullet in the first couple of spaces. So let's do that. Let's draw the bullet last and check for explosions last. And that way all of the effects of check for boom happen before the next refresh. Oops. All right. Yeah, there we go. Now we're seeing the bullet before it gets a chance to disappear, and we're deleting our shields nicely. Whew. Nothing like 2 hours to figure out how to get your shields to go, right, eh? But the beauty of assembly is that if you can do assembly, you can do just about any other language because they're all so much easier. Pew, pew, pew. Pew, pew. Pew, pew. Pew, pew. All right, well, we've done 216. Pew, pew, pew. Pew, pew. Pew, 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 pew. Pew, pew, pew. just shoot through the shields, right? That's what we used to do. Come over here. Pew, pew, pew. Right? Everybody just shot through the shields. Obviously, next we're going to have the bombs coming down and hitting the shields, right? But the first round is always just target practice, right? The little guys would just march across the screen, and then you'd shoot them, and they wouldn't shoot back, and you'd get a chance to blow them away. All that kind of fun stuff. So let's at least make it make a hit sound. So, oops, I could have just quit instead of, ugh, I hate when it does that. I have no idea why it does that. But let's see. We have, oh, I don't have, I should put the utility function in here that lets me play around with the sounds. But, let's see. Draw bullet. There's the bullet sound. Right 2E, the bullet sound. Let's go find the bullet sound. Oh, that is going to be in the assets. Bullet sound is 51. So, I don't know. We'll define some sort of constant. Oh, look, I'm defining a hex constant there. Is that 16 or 10? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Yes. Everything's in hexes. What do you know? EI, bullet, hit, shield. It's 5-1. I completely forget the pattern for these. I don't know. Let's try 5-5 and see what that does. And to do that, let's write to port 2, the immediate. So we're going to look for where was it? Shield. Check for shield boot. There's one. Here's our play the hit sound. W2E. Our bullet hit shield sound. There we go. Quit. Rebuild. All right. Over here. Hate when it does that. Yeah, sometimes it just gets out of sync with the serial, with the terminal, and it's weird. I don't like that sound, but we can play with it. Let's see, what does the go boom sound like? You know, we can just look for any time we do this. bullet sound. Shield up. 2, 3, 4, 5. Let's try 3-0, shall we? Is our bullet sound now. It's a different sound anyway. Yay. We are doing... And what we've learned is how to do this for any row of marauding invaders, right? We'll probably have to add something for the position of the marauding invaders as they move left and right and change their position. But I think that's pretty good, especially since we only have to hit them once to delete that entire character, right? And that'll end up with a little bit more math, and we'll have to figure out that whole range of characters to change to a space when they go blow up. But that was kind of what the I wonder if the check for boom still happens. Nope. Oh, there it is. So the boobity boop boobity boop. That's what's supposed to happen when I hit one of the bad guys, and that will delete everybody around him. So, or all of the spaces that make up the character. But only if I hit him in dead center. Yeah, you might as well make it more difficult, eh? Might as well have to hit the bad guy dead center to make him blow up, right? And we'll have to decide whether you can fire while the bullet is still in flight. That might be a thing. Yeah. All right. Cool beans. Thanks for joining me for however brief you may have joined us. We made some good progress. Be sure to like and subscribe and all that fun stuff. Follow me on X as well, and we'll talk about other things other than coding like this. And when you next see us again, hopefully we'll have the complexity of the shield degradation happening in several steps. And maybe we will start having our little guys marching across the screen and that kind of thing. But I think we'll probably just go with that first. All right. Thanks for joining me. We'll see you next time. Be sure to like, subscribe, ring the bell. Otherwise, you won't see when I'm coming on because I'm horribly inconsistent. Alrighty. Thanks again. We will be seeing you next time. If I can find the right window. Bye.